Google Classroom. Okay, so if you people open the Google Classroom, so in the UVM, go to classwork. Here, click the all topics. Here you have a meeting link. Okay, with the same meeting link, you guys have to join every day. You have a tracker here. Okay, if you open the tracker, you will be able to find your recordings. Okay, last session I have taken on 15th right now. So what topics I have taught, and this recording link is available here. Okay, for those who are joining in the live session and those who are recording, those who are watching the recording session, for both of the candidates I'm going to provide this recording. Okay, yes, so and the slides was not available last session, so I have not uploaded, but from today onwards even slides also will be updated over here. Okay, so with the help of these links only, please watch the recordings, because in the via email if you try to watch, what happens is you will not be having a clarity that in which day what topic has been completed. Okay, 1 minute, another column I'll write here, video name. In case if you lose the access, okay, please tell me the video name. Okay, then only I'll give the access. So video name, just a moment. Okay, so in case if you people not having the access, so just tell me the name of the video, don't tell the date or don't tell the topic. Okay, so please tell me the name of the video so that immediately I will be able to give the access for you people. Okay, yes, so this is how via tracker you will be able to access the things. Okay, still I have not given any labs or study material. Slowly as the days gets progresses, I will be updating it. Okay, yes, just a moment. Okay, so today's topic is intro. Okay, introduction, like like why exactly we are going for UVM. Okay, what is the full form of UVM? Even though in system Verilog we are working on verification, but still why exactly we need another subject for the verification? Okay, all those we will discuss, and main importantly with respect to your interview, difference between system Verilog and UVM test bench architecture. That's the most important answer, so that we will understand. Okay, and one more is class hierarchy. These two are the important questions with respect to your interview. Okay, one second. Yes. Okay, so first of all, one second, I will connect to Bluetooth. Okay, labs will start from tomorrow onwards. Okay, so today only the intro and theory part. Okay, so first of all, what is this UVM? UVM means universal. Okay, universal verification methodology. Okay, first of all, remember this is not programming language. Okay, definitely this is not at all the programming language. SV is a programming language. UVM is not a programming language. This is just one subject. It is a verification subject. Okay, so it is only subject, it is not programming language. This is the one point that you have to properly remember. Then if it is not programming language, then what exactly we are studying here means how to effectively use a system Verilog. That is what we are exactly studying in the UVM. Okay, UVM is, even if you open the UVM codes also, SV coding only you are doing, but some extra inbuilt methods. Okay, so in the system Verilog, we have studied about some concepts like enum. Okay, enum is having some inbuilt method. Some strings is having some inbuilt methods. Right now, there topic by topic we had the inbuilt methods, but here complete file itself we are taking into consideration for the inbuilt methods. Complete file. Okay, suppose if you want test file, for the test file I am creating a class hierarchy inbuilt. Means in the test basically, or else let me take driver. Okay, so in the driver, what exactly is the functionality of the driver? It is going to collect the data from the generator and it is going to send it to the DUT. That is its functionality, correct? That functionality is already written in some class, inbuilt class, that is UVM underscore driver. Inbuilt class is there here. In system verilog, only topic by topic we had the inbuilt method, but in UVM, for complete file itself, I am having a inbuilt binary, so inbuilt base class. Okay, so it's called as base class. Okay, nothing but your inbuilt class. Okay, so like this, how efficiently I can use system verilog, that is what I'm studying actually in the UVM subject. Okay, and remember UVM is now, and without UVM also still with the help of system verilog you can work, but the problem is system verilog takes more time as compared to UVM, because in the UVM, as I told, all the inbuilt base classes are present, correct? So obviously it will consume less time as compared to system verilog architecture. Okay, system verilog plus UVM you can work, or else alone using system verilog also you can do the project. But if you use only system verilog, it is of less cost and obviously it will take more time. But UVM is actually costlier as compared to the system verilog, but we can complete the project soon. The time consumption is less. That's the main thing. Okay, yes, there is some doubt here. Okay, not a problem. At the end you can just remind me for the attendance. Okay, yes. Okay, so that's about the UVM. Okay, so and as I told, what is the limitation? See, coming to limitations of system verilog, major limitations we are not having. Only thing is, just like, see, in the system verilog, what was my agenda? My agenda was to improvise the verilog, improvise the C language, improvise the C++ language, correct? No, in the system verilog, that is what I have taught you people every time. For example, task and function concept, what we have done, same concept I have taken in system verilog and I have improvised it. Event scheduler concept, regions concept, four regions we were using in the verilog, but in SV what we did, seven stages we are using, seven regions we are using, correct? Nothing but I'm doing the improvement. The same way system verilog complete subject is improvised with the help of this methodology. Okay, UVM methodology. Okay, without UVM also still you can do the project. Okay, it is not like compulsory you don't need UVM, but if you have a knowledge of UVM for SOC level of project, it is helpful. Okay, yes. So now, reusability and portability was also present in SV, but in the UVM, what happens? It increases usability. That's it. We should not tell that completely system verilog is waste. Compulsory we need UVM. No, it is not like that. UVM, when you utilize, what happens is more and more efficient in the effective way. We can use the system verilog. Okay, and that reusability is called as plug and play, which means what? So this is, as I told, same example. Router 1.0. Okay, you are doing some router 1.0 project, DUT is written, test bench is written. Okay, same test bench if you want to use for router 2.0, still you can use. That is only called as plug and play. Okay, so some random test case or some particular random test bench you can plug in and you can just operate it. Okay, so same system verilog example only I'm explaining here, same thing. Okay, but here very important point is with respect to the architecture question. Okay, one most important advantage you have. What is that advantage? Means I'll tell. Usually in system verilog, how we have planned the hierarchy, you tell me. First comes top, then test bench and DUT. Inside the test bench we have test, inside test ENV, inside ENV we have transaction generator, driver, input monitor, output monitor, scoreboard. This is the hierarchy, correct? Here what happens? See, basically in the industry, test case writer is different person, okay, or different team, okay, and TB development is a different team. Okay, the one who developed the TB, they will be knowing about all the files. Okay, but the one who want to write the test case, what they need to know what are the scenarios, for what scenarios I need to write the test case, and what all stimulus we are generating. These only two informations we need. We don't need all the information. The one who is writing the test case, no, they no need to know what is written in driver, what is written in scoreboard, what is written in output monitor. It is waste information for them. They don't want all those information. They need only that information, which is these 2 points. Okay, what scenarios, for what all conditions I should write the test case, plus what stimulus are getting generated. These 2 points we need to know. I mean, indirectly, if I have to tell, the transaction plus generator file only they need. That's it. Remaining files they don't need. Okay. In system verilog, what is the problem means the test case writer has to travel so long. Test bench inside test, then env, then you will get the no transaction in the generator. Okay, but in the uvm what are we doing means these two files I am dragging outside, means independent of the environment. You don't even have to go inside the environment. Outside the environment itself, means here I'm keeping transaction in the generator in the uvm hierarchy, in the uvm test bench. By doing this, what happens, without the test case writer, without even going inside the env, they will be able to access the transaction in the generator class. Okay, so you do not have to give the access for all these files. It is actually waste for the test case writer. Okay, this point is called as in the uvm we are independently generating the test case, independently generating the test case, generating the test case without the help of env, or without even going inside the env. So this is the most important point. Okay, whenever they ask you the advantage of uvm, this point should 100% come there. Okay, because this is a major drawback that we are eradicating in the sv architecture. Okay, architecture hierarchy is same, but some changes we are doing to improvise the quality of the test bench. Okay, so first make a note of this and we'll discuss about the complete figure of the architecture. Okay. Okay, so before coming to UVM, so all these languages were present: ERM, RVM, OVM. OVM, in fact, now also they are using in some of the companies. Okay, open verification methodology is still used in some of the companies. Okay, but URM and AVM is not used. OVM is used and UVM is used. But as of now, UVM is only the trending subject which we are utilizing for the verification. Okay, yes. So you can go through the same points only. Okay, but here if I make you people understand about all these base classes, you will not understand, because same point in the system verilog I told, na, when I was explaining the advantages of system verilog, I told that coverage, assertion, okay, still what points were the reusability, all these it's a separate topic. The same way here also it is in the first day you will not understand what is class hierarchy, okay, what is factory registration, okay, what is driver sequencer handshaking mechanism. All these points you will not understand. Okay, these are separate topics in the uvm. Okay, once you complete those topic you get to know, okay, these are the advantages in the uvm. Okay, one more point if I have to tell, so in the system verilog usually we are using the mailbox to do the communication between the system, this one, what is the generator and the driver, correct? Now from the generator I'm going to send the stimulus to the driver with the help of mailbox. But in the uvm we are not having mailbox. Why? Because suppose in the ip level of project, if you want to do the communication from system verilog to some perl subject, perl language, perl code, okay, will you be able to do the communication using mailbox? Definitely no, because mailbox works only for sv to sv file communication. Okay, so we are removing that mailbox, and in the uvm we are getting one new concept called tlm, transaction level modeling. Okay, so this is a new concept that we are improvising in the improvise whatever the mailbox concept was present, same concept, but we are little bit improvising and we are changing the name as tlm. And this tlm can communicate between sv to sv, sv to some other language files also. Okay, but still whatever the inbuilt methods we have in mailbox, put method, get method, peek method, same methods I'm using here, same methods, no changes, but I am improvising same thing. If from verilog to sv, what we did, what all were present in verilog, I improvised that in sv, correct? Now also the same thing I'm doing in the system verilog, what all things are present, the same things I'm improvising in the uvm. Okay, so from one subject to another subject, here we are improvising the topics. Okay, so improvisation is happening here. Okay, and one more thing, So this is just randomly I'm going to send the data. But now only for sending the data from generator to driver, I have a separate concept called driver sequencer handshaking mechanism, which is very very important. This handshaking is there na, that word handshaking is very very important for your protocols knowledge. Okay, in future if you enroll for the protocol courses, in the protocol every now and then you will be getting this word handshaking. Okay, this handshaking is very very important for your protocols. Okay, see, handshaking means what? In general words, if I have to tell, this is my master and slave, or this is my source and this is my destination. Okay, however you can want, you can call. So from when the data is going from one place to another place, okay, you will send the data, fine, but you should also get some response now. Then only you will get to know, okay, the data that I have sent is properly reached the destination. Okay, this kind of behavior is called as handshaking behavior. Okay, in system verilog, did we had that? No. What, simply we have sent the data from generator to driver, but did the driver give me any confirmation to the driver, did it give confirmation to the generator? Obviously no. Okay, but here whatever the data you are going to send to the destination has to give you the response telling that, okay, present transaction is completed, now you can send the next transaction. So this kind of behavior is called as handshaking mechanism. Like this, some advanced level of concepts are added in the UVM. That's it. But what we are taking, the base language is again SV only. Okay. Today I will also show some of the codes. Okay. When I will now explain the class hierarchy. Okay. When I explain the class hierarchy, I will show the codes, some of the codes. There 100% SV is only used, but with the improvised inbuilt methods and inbuilt classes. That's it. Okay. So that is how UVM is actually been evolved. Okay, different, see, in the industry currently some of the client projects are like that who are using only SV architecture, and some client projects are like that they will be having more budget and they will ask you to use UVM. So depending upon their requirement we are supposed to work on it. Okay, yes. So let me go to the next slide. This was just an intro. Okay, but in the intro majorly advantages and all means this one point compulsory you have to remember, because remaining points are okay, same advantages. If I ask you SV and verilog advantage, what advantage you are going to tell na? Same advantage you have here also, but this independency of the test case writing is very very important advantage. Okay, apart from this driver sequencer handshaking mechanism concept, mailbox and TLM concept, all these points you can take. Okay, majorly if you want to write the advantages, okay, first one, that test case independency that you can write. Okay, we can write the test cases independently from the architecture, independently without the help of env. That is one major advantage. Okay, second is mailbox and TLM, that advantage you can tell, mailbox and TLM. Third is we are having driver sequencer handshaking mechanism, means handshaking procedure is been introduced in the UVM which was not present in SV. Okay, so this is something that you can write it down here. Like this many topics are there, many topics. Okay, and very most important, we are having something called phases concept. Phases concept means already I am having an hierarchy, means top, inside top, test bench, inside test bench, test, inside test, env. Okay, I'm having the hierarchy, correct, but do we have a synchronization between the hierarchies? Means in the test bench I am creating the test, in the test I am creating the env, in the env I am creating the transaction scoreboard generator and so on. Okay, this hierarchy is maintained, okay, I agree with the point, but is the synchronization maintained? No, actually. Synchronization in the sense, suppose this is my driver. Okay na, this is my driver and I'm having my monitor, I'm having my monitor. So three drivers and three monitors I'm utilizing for the same RTL code. Okay, three driver, one, two, three, all the three driver are sending the stimulus to the my RTL code, some RTL code, maybe this is some FSM, this is some register, and this is some FIFO. Okay, for FIFO one driver is sending the stimulus, for register one driver is sending the stimulus, for FSM one driver is sending the stimulus. Okay, and the three blocks are also working in different frequency, different delays. Okay, 40 nanosecond, this is 50 nanosecond, this is 10 nanosecond. Okay, now just imagine, as soon as who will complete the work first? Of course FIFO will complete the work first. Okay, at 10 nanosecond FIFO will complete the simulation. As soon as FIFO completes the simulation, do I have to send the output to the monitor? No, I should wait for register and FSM to complete the simulation. Okay, that is called a synchronization. The understanding between the components is called a synchronization. This synchronization is actually not maintained in system Verilog, but here in UVM we are having some concept called phases. With the help of that particular phases concept, what happens is FIFO, register, FSM, all the three components has to complete the simulation. Then at a time they will send the output to output monitors of its particular file. This is one such example. Okay, so this kind of synchronization is been maintained by the phases concept, which is actually not present in SV. Okay, in the SV this is a major problem that we face. Okay, as soon as I send the stimulus, once the simulation is completed, immediately I will get the output. But if that is the case, just imagine, monitor, three monitors I'm having. See, all the monitor has sent the data to the scoreboard, then only the comparison will happen. Correct na? Now, if FIFO is completing the work, FIFO will send the output to the output monitor. Output monitor will send the data to the scoreboard. Now, in this point of time, in 10 nanoseconds, scoreboard is having only one data. Score in the scoreboard, still I didn't receive these two data. Correct na? Then how it will do the comparison? Getting my point? Okay, so that is why at a time if I send all the three data, those three data will be compared in the scoreboard. Okay, so that is what actually called as synchronization, which is actually maintained here in the UVM. Okay, so these are the some of the 4 points that you can mention. Some of the 4 points I'm telling, there are many n number of points, because every day whatever I'm teaching, all these are new concepts that are enhancing your SV subject. Okay, one by one you have to make a note of the topics only, in fact. Okay, so make a note of this. So that's about a simple advantages. Okay, as the days progresses you get to know, because in the one day only you'll not understand all the uh,
Ma'am,
yes, tell me.
what is the TLM? TLM is what?
Transaction level modeling.
How can you repeat it?
Transaction level modeling.
Okay.
Yes. So now, one moment. So those are some of the simple advantages. So please make a note of it. Okay. And one more thing, guys. First week, still it is a first week. I'll not take any review. But from the coming week onwards, I will start taking the reviews. Okay. So make sure to prepare the syllabus on that day itself. Okay. I'll not inform. I'll not inform that I'll be taking the review. No. Suddenly I'll be taking the review. Even the one who is watching the recording sessions, you people also have to give the review. Not only live session candidates, even the um, recording session candidates also have to give the review. For the recording session candidates, I will inform the date and time in the WhatsApp group, but for the live session students I will not inform. Okay, at any point of time I can take a review from 23rd onwards. Okay, so first 1 week I will not take. From the second next week Monday onwards I will start taking. Okay, just a moment. Okay, still some are texting for adding in the group. Okay. Okay, this advantages point, even in SV also I told the same. Okay, in the first day you should not memorize the advantages, because even if you memorize it is waste only. Simply for namesake you have to memorize, that you don't do. Okay, in SV also I'm telling the same, in UVM also I'm telling the same. Okay, first day you just understand okay why it is actually exactly existing, that's it. Advantageous point at the end you have to study actually. Okay, because by the end of the syllabus you will be completing the full syllabus and you have a clarity that in which topic what exactly enhancement is happening. Okay, yes. Now, already we people have discussed about this SV architecture, right? Now coming to UVM architecture. So let me draw it by myself. One second. Hmm. So, hmm. So in system Verilog, we had first top, inside top test bench and DUT. Okay, inside test bench we have test, inside test we have ENV, inside ENV we have transaction, generator, driver, input monitor, output monitor, scoreboard. Okay na? And to communicate between the test bench and DUT we had an static interface. Okay, so to communicate between the test bench and DUT, we had something called static interface, and to communicate inside the test bench, we had something called mailbox, and we had used the virtual interface handle in the driver and in the output monitor. Okay, because they are directly communicating with the DUT, so for that sake, we are using the virtual interface dynamic handle in the driver and the output monitor. This was the architecture, but now in the UVM, what we are doing, same hierarchy. So we are having top, inside top test bench and DUT. Inside test bench we are having test. Correct. Now in the test hierarchy, as I told, transaction and generator I am removing from here and I am keeping here because just now I told no I am giving some advantage for the test case writer. Okay. Now the transaction is not called as transaction. The transaction is called as sequence item in system in UVM. Generator is called as sequence. Okay, that is just replacement words, that's it. Now sequence item means what? Transaction. Sequence means what? Generator. In system verilog I call it using transaction and generator. The same files in UVM I call it as sequence item and sequence. Same files, no difference, only the name is getting different here. Okay, now in the test hierarchy I will be having a sequence item and I will be having a sequence. Okay, now inside the test what I'm having, ENV. Now inside ENV another extra layer I'm having, that is called as agent. In the agent again two types are there, active agent, passive agent. Okay, if it is an active agent, inside the active agent I will be having driver, monitor, and one more thing is sequencer. Sequencer. So you should not get confused between sequence item, sequencer. Three are different things. Sequence item means transaction, sequence means generator, sequencer is the bridge. It's a bridge between the sequence and driver. Sequencer, driver. Okay, sequence means what? Generator. Driver is driver only. Generator and driver is doing the communication. Am I right? Here in UVM, we are not using mailbox. Okay, of course, we are using TLM instead of mailbox. We are using TLM, but for the driver sequencer handshake, actually, this driver sequence communication is now called as driver sequencer handshaking mechanism. Okay, that driver sequencer handshaking mechanism is happening with the help of this bridge called sequencer. Sequencer is a bridge between the driver and the generator, or between the driver and the sequence. Okay, if it is an active agent, inside the agent I will be having driver, monitor, sequencer. Suppose if you want to take a passive agent, in the passive agent you will be having only one monitor. Okay, can we take multiple passive agents, can we take multiple active agents? Yes. How much ever active agents you want you can take, how much ever passive agents you want you can take. Okay, usually for the multiplexer project, if I ask you people to tell me how many active agents and how many passive agents, definitely you will tell one active agent and one passive agent. Why? Driver will send the data, let us consider this as input monitor, another will be output monitor, that's it. Okay, one more driver is not required, correct? One driver is enough for me. So like that you have to think how many active agents we need to take and how many passive agents we need to take. Okay, that's about the extra one layer. See, one changes that I made it this one. transaction and generator I pushed outside, okay, to create some advantage for the test case writer. Okay, one more changes that I made is I have added extra layer of hierarchy that is called active and passive agent. Okay, compulsory it is not like active agent passive agent both you should take, not like that. Either you can take one active agent one passive agent, or you can take n number of active agents n number of passive agent, or you can take only active agent, or you can take only passive agent. That's left to the project wise according to our specification we will be taking it. Okay, but end of the day it is like we are supposed to decide depending upon the scenario that we have in front of us. Okay, so apart from this what we have a scoreboard. Okay, so if I show the proper diagram now, yes. Okay, so top inside top test bench and dut, again same have interface. Here we are using the, instead of mailbox we are having a tlm. There I had written mailbox. Right now in UVM I'm writing TLM. So this is again a static interface. Okay, same files only. So how did you people write the static interface? Using clocking block and the mod port, correct? Here also the same thing. Interface is written using clocking block and mod port. Same files. Some improvisation we are making. That's it. Okay. See, in the test hierarchy, I have kept my transaction and generator file. Okay, because still I am using the word transaction and generator file because you people are new to the words. Okay, but in the UVM, transaction is called as sequence item, generator is called as sequence. Okay, and active agent you can see sequencer I'm having, driver monitor, passive agent only monitor. Again the functionality is same only, same explanation in SV what communication explanation I have given, same explanation here also. Okay, so with the help of driver sequencer handshaking mechanism, okay, the stimulus is sent from generator to the driver and from the driver to DUT to input output monitor, output monitor to scoreboard. Again here reference data I will generate and I will send to the scoreboard. Same explanation. SV and UVM explanation will not be different. Okay, what differences are there means two major differences we have made in the architecture. Okay, three you can take, three differences. First difference is that the sequence item and sequence I kept it in the test hierarchy, which was previously present in the inside the env actually. Okay, one more changes is instead of mailbox I am using the TLM concept for making the communication inside the test bench. Okay, another changes that I have done is adding the extra hierarchy, that is agent extra hierarchy is there, that is agent. Okay, again agents are of two types. Okay, so and what is subscriber you can even take in the SV also. It is just one file where you will be writing the coverages. If you want to write a separate file you can write, or else you can exclude. It is not compulsory that you have to take. If you want to write you write it, if you do not want to write also no problem. Subscriber is one file where you can write the coverages, that's it. Okay, if you do not want to write coverage in the subscriber, you want to write the coverage in the scoreboard, means you can write inside the scoreboard itself. Okay, yes. So till, and one more thing I will repeat again, sequence, sequencer and sequence item, these three are different. Okay, sequence means what? Sequence means it's a generator. In SV we call it as generator, correct? Sequencer means it's a bridge between the driver and the sequence, I mean driver and the generator. Sequence item means what? It's a transaction. Okay, so these are the three differences that you are supposed to make a note of it. Okay, so far is it clear about the architecture part? Please respond in the chat box. Others, is it clear about the architecture? Okay, and first of all make sure to remember these words now. Sequence item means transaction, sequencer means driver and bridge between the driver and sequence. Sequence is a generator. We are just changing the words, but still the operation remains same. Okay, sequence item nothing but transaction file. In the transaction file we are writing the pre-randomization concept, that is declaring of rand and rancy and constraint. That's it. In the sequence, for writing the sequence in the UVM, we are having totally three steps. For writing the test case, we are having four steps. All that it's a separate topic. Okay, as the days get progresses, I will teach. Okay, because the way that you write the code in UVM is a standard method. Standard. One time properly, if everyone is attending the live session, it is enough for another 5 years for you. That is how standardly the codes are developed. Okay, the same code you can use in your client project also, because it is constant. See, if I'm telling there are three steps to write the sequence, means it is constant. But in system verilog, that was not a case. Every time generator logic will be changing, obviously, but here it is not like that. The steps that I'm going to design, right, it is constant. That is why we go for UVM. Okay, UVM codes are developed in such a way that the codes that we are writing is constant codes, standard codes. Okay, so that is the value that we have for the architecture, UVM architecture. Okay, so as I told, you can use n number of agents. Okay, so that is what they just want to convey. Okay, and here in SVUVM, same files only, but we are changing the words. Transaction is called as sequence item. Okay, sequencer is nothing but generator. Okay, sequencer means it's a bridge between the generator and the driver, or between the sequence and the driver. Okay, see, we are having some extra concept, those we have listed out. That's it. An extra hierarchy we are using, that is agent. Coverage, if you want, you can write inside the scoreboard, or you can write inside the subscriber file. Okay, so TLM ports, factory registration, and config DB is a separate concepts again. Okay, so all these concepts extra we are adding in UVM. Same concept we are taking, we are improvising the concepts. That's it. Exactly what we did in SV. The same thing we are doing in UVM also. In SV, we have improvised the Verilog and other programming language. In UVM, we are improvising the system Verilog itself. That's it. Okay. Next, so here some of the differences again I have listed out. You guys can go through it. As I told, phases concept is present here. Okay, which was not present. See, phases again you can't understand completely. I need 1 hour for me to explain the phases. Again I have to explain the lab. Okay, that's what I'm telling. In one day only you will not understand everything. Okay, so this point you will understand once we complete the syllabus actually. Okay, so UVM is a methodology, SV is a programming language. Okay, so here reusability was also present here, but we are more, as compared to SV, there is more reusability in the UVM. That's it. Okay, so in the UVM we are having driver sequencer handshaking mechanism. Mainly that handshaking word is very important, which is introduced in UVM, which was not present in SV. Okay, so we have some phases concept which will maintain the synchronization. In SV it is not there. Okay, in the system Verilog we are still using dollar displays, dollar monitor, and dollar stoops, correct na, which was a Verilog subject. Did we improvise that concept? No, we didn't improvise. Do you people remember, right? So but here in the UVM you will improvise that. Okay, dollar display, dollar stop, dollar monitor, we actually didn't touch that topic in SV, correct? No, simply we are blindly using dollar displays. But in UVM we will also improvise this displays. Okay, that is called as messaging and reporting concept. Okay, and one more is there, verbosity. Okay, so these are the concepts that is concentrating on the display statements. Okay, so this is one important point. Okay, and as usual, mailbox was used there in SV. Here I'm using TLM concept. Okay, so there is something called factor mechanism, and configuration is again separate topic. Okay, that I will discuss separately, because each topic will take one lab and 1 hour of theory explanation for me to make you people understand. Okay, so these point at the end of the syllabus you have to once again read it. Okay, today I'm just telling the brief points about SV and UVM difference. Understanding perspective, you need at least some another 1 week to at least understand the one topic, that is driver sequencer handshaking mechanism. Okay, yes. So those till here I just told two major questions. One is difference between SV and UVM, which I told not to read now. Okay, second questions I told is UVM architecture. Main very important question. Majorly here they will ask you to explain what is the difference between the UVM architecture and the SV architecture in the interview. Okay, so make sure to read these two questions. Plus now I will teach you what is class hierarchy. Already we have a hierarchy, but for that hierarchy once again we are adding a hierarchy. Why we need, I will tell. So here you can see some figure. Okay, so this is called as UVM class hierarchy. In short, if I have to tell, just a few minutes before I have told you people that in UVM we are having a base classes. I told base classes, correct? That base classes is nothing but is this class hierarchy. In the class hierarchy, what happens, for every file, for driver file, okay, for test file, for env file, for sequence item file, for generator file, that is sequence file, for scoreboard file, for every file already there is a base class, means inbuilt method. Okay, in system verilog only for one topic we had inbuilt method. Now for the complete file itself I am having a inbuilt methods. Inbuilt method I don't call it here, I call it as base class, which is already written in the subject. Okay, what should I do now? I just have to make all these classes as a child class. Child class, these child classes will now extend from the parent class, and now who is a parent class? These are the parent classes. Okay, now for example, if I tell driver, driver will extend from here, you can see, no, one second, let me search. Here UVM driver, UVM underscore driver. In the UVM underscore driver, already the major logic of the driver is present. What should I do now? I just have to write the signals, that's it. Automatically the driver will do its work. Getting the point? See how much work is reduced for me now. Okay, so completely the base class itself is present. All these are inbuilt base classes, I don't even have to write it, it is written. What I should do, whatever the class I am creating, I just have to make them as a child class, and I have to extend that from the base class, parent base class. Okay, so here actually above this we have one more class, UVM void. Okay, it is not visible here, you should write it. The topmost class is UVM void. Okay, so below UVM void you have UVM object. Okay, below UVM object UVM transaction and event, below that UVM component. So this is a hierarchy. Okay, I'll show the code also for that now. Okay, and here see basically what happens in the complete UVM architecture that you see here, all are components except two, that is sequence item and the sequence. I mean to tell the transaction and generator, these two are the object. Object. This is not the this is not the component. Okay, see majorly we are having something called object, here we are having component, correct na? In the hierarchy, all the other files like test, env, scoreboard, agent, all are component, but sequence item and sequence, where it is? Here, sequence item and sequence, these two are object. Object. Okay, now for now what is the difference between that object and component means UVM object and UVM component, what is the difference I will tell. Okay, so first is you should list out, so sequence item and the sequence, these two are object, remaining all the files are component. Example, agent, test, scoreboard, dash dash dash, driver, monitor, all these are components. Okay, second point, we have something called new constructor in system verilog, correct? Why are we using new constructor in system verilog? To create a memory or to allocate a memory, right? Here also we will be using new constructor, means whenever a file is created, I'm going to create a constructor, custom constructor, correct na? Now when you are creating a custom constructor for object, you will use only one argument. I'll show that now in the code. Okay, but for the component, when you are using the custom constructor, you will be using two arguments. I'll show the difference now, don't worry. Okay, next, if you have an object, you will do the factory registration, I will tell what is that. Okay, again it's a separate concept. So we are going to do the factory registration using tick UVM object utils. Tick UVM object utils. In the component we will do using tick UVM component utils. Component utils. And the fourth and last point is phases concept cannot be used in the object, but it can be used in the component. Okay, now one by one, let me make you people understand with the help of a code. Okay, I repeat, first one is, first you should understand, in you know all the files now, correct? In that file you need to understand which is the sequence, only which is the object and which is the component. First point, sequence item and sequence is an object, remaining all are remaining all the files are component. That is the first thing. Now what is this custom constructor? Let me show you people. Some random file I will, some random project I will take just to make you people understand. That's it. Okay, see, I have created one class, any some random file I'll take. Wait a minute. Huh. Some random sequence item file. Okay, sequence item file. 1 minute. Some simple files I'll take, because starting only, if I take complicated. Huh. Okay, some random environment file I have opened. Environment is what? Environment is a component, correct na? For component, as I told, I'm doing the registration. This line is called as factory registration. In short, if I have to tell what is factory registration, for example, if you purchase a vehicle, okay, one vehicle you will purchase. Okay, when you purchase a vehicle, just imagine you have taken a second handle vehicle, second hand vehicle. Okay, if that is the case, the owner will sell you the vehicle. Okay, when the owner is selling you the vehicle, simply you give the money and you take the document, that is not enough na. You have to transfer the registration name on your name. Means whatever the documents is there, that name also has to get transferred. Means in the RTO office, in the government RTO office, they have to register that the old person is not the owner. Now the owner has sold the vehicle to some other X person, and this X person will be the owner. That registration should be happened in the government office, that is RTO office, for the vehicle, correct na? The same, if that is the case, under the government, if you have registered, then only you will be able to claim all the facilities like insurance of that vehicle. Okay, what all things you want to make for that particular vehicle, you will be able to make it. Suppose illegally, if you simply take the amount and if you just give the take the vehicle, if you give the amount and take the vehicle, that is of no value. Suppose in future if you want to claim the insurance or something, you can't do that, because legally you have not registered under the government, correct? The same happens in UVM code also. Whatever the code you are writing, first you should do the factory registration. Only two syntax, either using TickUVM object utils or using TickUVM component utils. When you do the registration, now you are capable to use the inbuilt methods that are present inside the base classes. That is the main point. Okay, so here if you do the registration, now you are eligible that under the base class. Okay, as I told, I'll explain this point, don't worry. Okay, so as I told, if you do the registration, then only now you are eligible to use all the inbuilt methods that are present in the base class. So just now I told, now in the class hierarchy diagram. Okay, so we have all these base classes. Okay, now if you just observe the files, class and class, remove, leave everything, just don't forget about everything, just class and class, you have written your file name. That extends from, which means what, I am creating my file has child class directly. Okay, class and class, name of the class extends from UVM agent. What is this UVM agent? UVM agent is the class hierarchy. Okay, in the UVM agent already all the inbuilt methods are written. What you have to do, you just have to use that in your code. To use that, you should do the factory registration. If you register now, your code is considered for the for using the inbuilt methods. That's how it is. Okay, next another file, see again same thing. Driver, I will tell what is this. This you do not have to worry now. Okay, so in the driver file, again driver extends from UVM driver. Okay, next environment extends from UVM environment. Okay, monitor extends from UVM monitor. Another monitor also extends from UVM monitor. All these are base classes which are present in this diagram, class hierarchy diagram. Okay, so now depending upon which is the object and which is the component, you are supposed to do the registration. Okay, only sequence item and sequence, let me show you that. Sequence item and sequence will be doing using the registration TickQVM object utils. See, this is a sequence. It's a sequence item. Sequence item also I am doing using object. Remaining all are components. That's what I told here. The point. Okay, difference between the object and component, that is what I told, registration point. Okay, that TickQVM object utils we should use for the object, TickQVM component utils we should use for the component. Okay, now one more point I want to tell you people is, usually what happens if you check the hierarchy again. Okay, one second, where is my pen? Usually what happens, the generator, driver, or in UVM language if I have to call, sequence is nothing but generator. Okay, sequence and the driver, this is the hierarchy, correct? Sequence and driver will do the communication with the help of the bridge called sequencer. Okay, now what communication we are doing? See, basically in SV or UVM, whatever it is, what data we are sending from sequence to sequencer, sequencer to driver, what data? Stimulus data. Stimulus, correct? In SV also stimulus only, in UVM also stimulus only. Stimulus is called as what? Your transaction or sequence item, correct na? So only in the class hierarchy, first line, in the sequence, sequencer, and in the driver, you should write a parameterized class of a sequence item, telling that it is constant. Whatever communication I'm doing in between sequence, sequencer, and driver, that communication is about the sequence item, to indicate that in every project, for the driver, okay, for the driver, for the sequence, and for the sequencer, I didn't take sequencer, wait a minute, for the sequencer, okay, I will be writing the parameterized class of the sequence item. See, parameterized, it is constant. This communication only I'm doing here. Okay, see, sequencer. Okay, so first what you will do, class driver extends from UVM driver. Okay, class sequence extends from UVM sequencer. Okay, class sequencer extends from UVM sequencer. Okay, this is fine, class hierarchy concept. But unlike other files, in the other files that is not required, parameterized class is not required. Simply the class extends from so and so base class, that is enough. But in the driver sequence sequencer only, you are supposed to write the parameterized class of the sequence item. Okay, this is the class name of the sequence item, your transaction class. See here, mux underscore sequence underscore item, this is your transaction class file name, sorry, class name, correct? The same class name I am utilizing here. See, mux sequence item, mux sequence item, mux sequence item. Okay, the reason for writing that is because we already know that sequence, sequencer, driver communication is having for the stimulus only, and stimulus is nothing but your transaction, transaction nothing but your sequence item. That is why in the first foremost line you should write like this. Okay, so first thing what you have understood now, in every file from now onwards, you have to use the class hierarchy. That is, sequencer extends from UVM sequencer, scoreboard extends from UVM scoreboard, agent extends from UVM agent, and so on. First point. Second point, driver sequence sequencer, in these three files you should write the parameterized class of the transaction or parameterized class of the sequence item. That is second point that you have understood. In remaining files that is not required. Okay, that is second point. Third point, only sequence item and the sequence are the object, remaining all are component, correct? So when you are doing the factory registration, TickQVM component utils should be used for all the except sequence item and the sequence. Okay, so this is the sequence, I am using TickQVM object utils. This is a sequence item, I am using TickQVM component utils. In remaining all the files you are using TickQVM component utils. Okay, so this is what you have understood so far. Okay, now what was the next point? Phases. As I told, phases concept you cannot use in, you will get to know what is phases. Okay, phases concept you cannot use in object, but phases concept can be used in component. Okay, and one more very important point is custom constructor. Now what is that? See, in SV project also I have explained that whenever one file is created, for this file memory should be created. How can you create a file memory? Using a custom constructor. Now what is that custom constructor? Just function, end function, new is your constructor. Okay, two arguments you should write, that is string name, your class name. Actually this is apb, 1 minute. What? Huh, that is wrong actually. Okay, huh. String name in the double quotes. If you are interested, you write your class name. If you are not interested, you can remove that. This is enough. String name is also okay, or string name equal to the name of your class, that is also fine. That is your first argument. Second argument is UVM component parent. What does this parent indicate? That parent indicate UVM agent's parent. Who is UVM agent's parent? UVM agent's parent is its upper hierarchy. Who is that? UVM env. Getting my point? UVM env. You understand like this, or else do one thing. This memory, this agent one memory is there na, where you are creating, means imagine this is a parent class, correct na, this is a child class. Child class memory is created where? Inside the parent class, correct? So now this UVM agent is indicating your second argument list. UVM component space parent. Parent means for this who is a parent? For agent 1, who is the parent? UVM agent is the parent, correct? That is what it is indicating. And next line, super dot new name, this one, name comma parent. This is the exact syntax that you will use anywhere you go for IP project, SOC project, mini project, whatever the project you use. Whenever you create a file, one custom constructor should be created to create a memory for this particular file. That custom constructor looks like this. Okay, function and function, new, first argument, second argument, and the super. Suppose if it is an object, then what you should do? You should eliminate this. Eliminate this. This is how the custom constructor looks if it is a object. See, this is the object. Sequence is the object, right? Function and function, new, only one argument I have written. Parent I have not written because parent is not required. For the sequence, parent is not required. Only one argument you should write. That is about the custom constructor. And in every file, compulsory custom constructor should be present to create a memory for this particular class. Okay, so is it clear so far? All these points? UVM object and UVM component difference and the class hierarchy. The first line I just taught you people, only one line, that is a starting line. Okay, factory registration I just told the syntax, but don't think that I have explained. There is a lot of things that I should explain in the factory registration, but I should include that point, so I have included by telling the syntax, that's it. Okay, but only one point I told, why are we using the registration, but in future classes you will get to know 3 steps are there: create method, factory registration, factory overriding. These 3 steps you will be learning in the coming sessions. Okay, now I just told one syntaxes, and majorly I told one line. First line of every code should be having your class hierarchy, and main importantly in the sequencer driver. In these 3 files, parameterized, in addition to the class hierarchy, parameterized class of your sequence item should be present. Okay, yes, is it clear so far for everyone? Laya, is it clear? Any confusion so far?
No, ma'am.
Okay,
Clear, ma'am.
okay. So guys, everyone please listen carefully, because UVM is such a subject which is constant, standard. Okay, whatever I'm changing, syntax itself also. In system Verilog, syntax was not constant. For every project you have to change the syntax. Here it is not like that. Exact same syntax you will be using. Anywhere you go, any project you work, same syntax. Okay, so today with the help of class hierarchy, first line you have to update. First line. Only first one line. Okay, in the system Verilog, was this procedure present? No, all was a individual class, but here I am, all the class is a child class. Okay, which is for whom the parent is given as a base class. Okay, so that you have to remember. And one more thing, if you observe this diagram, okay, here you are having some methods, copy, clone, compare. That's what I was telling. For example, sequence item is there. Sequence item is an object, correct? Inside the object, all these inbuilt methods are there. If you want to use all these inbuilt methods, you have to do the registration. Okay, and ma'am, what is this copy, clone, compare? This is separate subject, sorry, separate topic. Tomorrow I will explain that. Okay, because every lab I should take for this. Okay, I should take a lab and then I will explain how to use this inbuilt methods. Okay, today I'm just telling this is the diagram, and according to our class code, first line you should update. These are the lines, these are the class hierarchy that you have to update in the line 1 of your every code. Okay, as I told, void is not present, you have to add. Here you can see above object void is present. Okay, here it is not present, I have written here. Okay, yeah, that's it. Okay, so that's about the class hierarchies concept. Okay, only now with respect to interview, what exactly you have to study in today's session means, let me make that note in the Google Classroom itself. Every day I will provide the interview questions here itself. Okay, in the Google Classroom. Okay, first one is UVM TB architecture and SVTB architecture difference. Architecture difference. Okay, and mailbox. I want everyone to write a running notes. Okay, don't write in a live session. After live session, please watch the recording once again. Means watch it in a speed like 2x speed or 1.5x speed. Okay, and write the notes. Then only you will be able to explain the concept. Because in SV also, in UVM also, main importantly, I'll tell students to don't depend on the slides. Write the notes. Then only you can explain the same answers. See, if I get some Google answers, I don't accept. If that is the case, you should not join course only. First of all, right, you can study from Google or chat gpt or YouTube. But when you are in a course, your intention is to understand and read. Correct, don't mug up the concepts, technical points I don't want. Tomorrow if I ask what is the difference between mailbox and TLM, what point I told in the live session, I want the exact point. Why I am telling like this is because if you understand what I am telling, you can even elaborate the explanation. Suppose if you take the Google answer, what happens, you tell me, you will mug up. Okay, but in the interview if they ask you to explain that point, will you be able to explain? No. Correct, that is why I recommend my students to write down the SV and UVM notes of my explanation. Okay, that explanation will be very clear, so that the same explanation you can tell in the interview. Okay, so mailbox and difference. Okay, and the class hierarchy, you no need to memorize, but you need to know. Like for UVM, for agent I will use UVM agent. For scoreboard I will use UVM scoreboard. For sequence item I will use UVM sequence item. For driver I will use UVM driver. That first line of the code. Okay, first line of the first line of every file you need to remember. Okay, that is one thing. And also in the driver, sequence and sequencer, that parameterized class of the sequence item will be taken. That you have to remember. Okay, that is about the class hierarchy. UVM component and object difference. Object difference. Okay, SV and UVM difference I will write, but don't study now. Okay, 1 2 3 points you remember, that is enough. SVM UVM difference I will ask. Is UVM a programming language? No, it is not a programming language. Okay, okay, still what else we have discussed? You should remember the syntax of factory registration for object and component. Okay, and the custom constructor. What is custom constructor and the syntax? What is custom constructor and the syntax of it? Syntax of it for both object and component. Okay, these are your interview questions for today. Okay, like this every day I will give the questions. Every day you people have to watch the recording and you need to complete it. Every day QOD, question of the day. Okay, QOD means question of the day. In that category I am posting it. Okay, every day it's your responsibility that you are supposed to complete these questions at any cost. Okay, anywhere. Again, if you want the explanation, definitely you can come back and ask me. First watch the recording. Okay, immediately once I complete the session, recording will be updated here. Even slides also will be updated here. Okay, watch that slide, take a reference of that slide. You can make a proper notes. See, slides don't depend on slides. Okay, but I want you people to write a proper running notes, and after that get back to me. Again I will clarify the doubts. Okay, and from tomorrow onwards, next topic is sequence item, that is transaction. In the transaction I just showed now that we are having the inbuilt method. How to use all these inbuilt methods tomorrow with the help of a lab I will explain. After completing the lab, that lab also I will provide here. Okay, you can download that lab. Again, you also can do the simulation. Okay, so like this the sessions goes on. Okay, and if anyone have not downloaded the tool, means just a minute. Tool I forgot to give here. 1 minute. I will post it now. Okay, I will post the tool. If anyone has not downloaded the QuestaSim tool, I want everyone to download it. Okay, I will post the YouTube link. The procedure is there. I will post that. Plus, I will provide the folder also. How to download this folder? Just click here. Here you have 3 dots. Okay, click here. Open in new window. Okay, here you have a download option. Okay, click on download. It will be downloaded in your laptop. Okay, so download anyway. It will take some time because it is a little bit huge memory. Okay, it will take some 10 minutes around. Okay, it will get downloaded. You have to download and follow the YouTube procedure that I will provide the link here in the classroom. Okay, so if anyone has not downloaded the QuestaSim, please do download it, because from tomorrow onwards you compulsory need the QuestaSim to do the simulation of the lab. Okay, and after that I will also ask you people to do some assignments maybe. Okay, after some 3-4 days. Okay, so make sure to download the tool today and keep it ready. Okay, Krishna, yes, attendance, no, wait man, 4 members are present, no, 5, 3, 4, 5, yes, once again, Krishna, yes, Krishna, I have given the attendance. Okay. Anything else, anyone, any doubts, anything to discuss? Okay, so I'll end the session.
Ma'am,
Yashwant.
ma'am, can you upload the recording videos of SV yesterday, day before yesterday?
No, pa, that is not, that is what, Yashwant, for you, in your tracker, it is